definition. An irrational number is, let's go back in time, back to when it all began, just around 500 BC. During that time in ancient Greece, the Pythagoreans ruled the world of mathematics. Their dictum of all is number suggested that numbers are the building blocks of the universe and that everything in it can be described as ratios of numbers. These numbers are what we call today rational numbers. But just like every dream has its end, so did the Pythagorean fantasy. Hippasus was the murderer of that dream. Hippasus found this one number that just violated Pythagoras' harmonious rule, one that was not supposed to exist. The problem began with a simple shape, a square with sides measuring 1 unit. According to Pythagoras' theorem, the diagonal length would be root 2. But try as he might, Hippasus could not find two integers whose ratio would give us root 2, and instead of giving up, he decided to prove it couldn't be done. Hippasus started by assuming that the Pythagorean worldview was true, and that there were two integers whose ratio would give root 2. He labeled these integers p and q. Assuming that we reduced the ratio to its simplest form, p and q could have no common factors. So because none of these is 0, we say that p equals root 2 times q. Squaring both sides, we get that p squared equals 2q squared. But because multiplying any number by 2 gives us an even number, p squared had to be even. And so p had to be even as well, because any even number times itself gives us an even number. So p could be written as 2a. So 2a squared equals q squared, which means that 4a squared equals 2q squared. So we have that 2a squared equals q squared, which makes q the same way as p, an even number. And so p and q are even. And because all even numbers have a common factor of 2, our first statement cannot be true. This is called proof by contradiction, and according to the legend, Pythagoras didn't appreciate being contradicted.